Starting with numerical number 9, a steel wire having cross-sectional area 1.2 millimeter square. Now here the area is given to you, that is 1.2 millimeter square. That is 1.2 millimeter into millimeter, right? So that is 1.2. For this milli it is 10 raised to minus 3, and for this milli it is 10 raised to minus 3. Now we are left with 2 meters, so now it is meter square. So it is 1.2 into 10 raised to minus 6 meters square. When you go from 1.2 millimeter square to 1.2, I mean to say from millimeter square to meter square, we'll have to multiply by 10 raised to minus 6, and the procedure is shown over here, how we come from millimeter to millimeter square to meter square. After that, this is the very important point in this numerical. Now the wire is stretched by a force of 120 Newton. Here the force is 120 Newton. After that, if a lateral strain of 1.455 millimeter is produced, now here you have lateral strain, and that is equal to 1.455 millimeter. So for that we can write 1.455 into 10 raised to minus 3 meter, and that strain is produced in the wire. Calculate the Poisson's ratio. Okay, now they are asking you to calculate Poisson's ratio, and the formula for Poisson's ratio is lateral strain upon linear strain. Now you have lateral strain with you. Now let's see what is linear strain. For linear strain, you have to okay, here you have force. Now force is in the formula of Young's modulus. One more thing, force is also force and area, both of them are seen in the formula of stress. So we can find out stress first. We don't have linear strain, but we have the formula for stress. I can call it as linear stress related to the length, that is force upon area, and the force given to us is 120, and area is 1.2 into 10 raised to minus 6. Now 120, when you take this 10 raised to minus 6 in the numerator, it becomes 10 raised to positive 6, and here it is 1.2. Now I want to convert this 1.2 into 12. So 120 into 10 raised to 6, I'll multiply by one more 10 in the numerator, because after point there is one digit. So now it is 12. 12 ones are 12 ones are, and this 0. So it is 1, 1, 2 and 6. So 10 raised to 8 is my linear stress. Now I have stress. They are asking me to calculate strain. What else is given in the question? Let's see. They have not provided us with any extra information, and one information is missing in this question is they should have provided us with the value of y, and that is Young's modulus, and that value is 2 into 10 raised to 11 Newton per meter square. This is missing in the question. So now we have stress. The formula for Young's modulus is linear stress upon linear strain. Now things will become more clear to you. Now we have calculated linear stress, that is this. We know Young's modulus, and that is given in a question, that is 2 into 10 raised to 11 Newton per meter square. We don't have linear strain, so we can easily calculate linear strain with the help of these two given quantities, that is linear stress upon y. Now linear stress is 10 raised to 8. Young's modulus is 2 into 10 raised to 11. When you take this to 10 raised to 11, okay, you cancel it over here. So how much is left? Now when you cancel, you have just 3 remaining in the denominator. When you take it in the numerator, that becomes 10 raised to minus 3, of course. And here you are left with 1 upon 2, that is nothing but half. So for that, you can write 0.5. So now you have the value of linear strain, that is 0.5 into 10 raised to minus 3, which we can directly substitute over here. So better I will solve it on this side of the page. Poisson's ratio is also denoted by this formula, by this symbol. Now in the numerator you have lateral strain, that is 1.55 into 10 raised to minus 3. 1.455 into 10 raised to minus 3. And for linear strain, we have 0.5 into 10 raised to minus 3. 0.5 into 10 raised to minus 3. This 10 raised to minus 3, 10 raised to minus 3 gets cancelled. I'll make 1.455. I'll make this 0.5 as 5 and multiply by 10 in the numerator, because after point we have just one digit. 5 ones are 5, 5 zeros are 0, point. Now this becomes 14. So 5 2s are 10, 5 3s are 15. So I'll go with 2. 5 2s are 10, now 4 is left, 5 9s are 45, 5 1s are 5. So here the value of Poisson's ratio is 0.291 into 10. So the answer is, let me check whether we are going right. Okay, here it is 0.291 into 10. We have 1 10 extra. Okay. We have done any of the mistake? No. Okay, so the answer we got, that is right according to the given quantities given in the question. So 0.291 into 10 will give you, now here you have 1 and that is positive. This is positive side of the number line. So we will shift the digit, of course, to the right. Now to how many digits? To just one digit. So this will be 2.91. And this is the value of your Poisson's ratio. Now if you check in your textbook, it is 0.291. Now to get this answer, that is 0.291, here they should have given us 1.455 into 10 raised to minus 4 instead of milli. Means if we use this quantity, which is in simple words, if we use this quantity, then this would be the answer, not this. So this is the wrong answer. According to the given, this is the right answer. Okay, there's no mistake in our calculation, so you can go with this answer.